Welcome back. In this lecture, I'll show you how to use a MAX7219 LED controller IC with a single 8x8 matrix LED display. You can combine these two components together to create large LED matrix displays, but in this lecture, we'll keep it simple. In a separate lecture coming up, we'll expand to multi-display setups. The controller IC is capable of driving up to 64 individual LEDs in various configurations. These can be configured in a matrix, as I'm going to show you in a minute, in a series of 8 7-segment displays, or in 64 individual LEDs arranged in any pattern you can imagine. The MAX7219 controller can communicate with the Arduino via the SPI serial interface. To make the most out of the hardware, we use a library called MAX72XX Panel, which you can download from GitHub. This library extends Adafruit's GFX graphics library, which is also available from GitHub. You need both of these libraries installed in your IDE to follow with the demo sketches. This lecture contains 2 demos. In the first one, I'll show you how to create shapes, simple animations, and text on the screen. And in the second demo, we'll create a simple visualizations from data coming out of an accelerometer. So let's get started. So the controller and the display come together assembled in a single module. The interesting thing about this module is if you remove the display itself, you can see that it's got a couple of sets of pins. So on this side here, we've got data in pin, just one of the pins that make up the SPI interface. And then you can daisy chain multiple of these modules together by connecting additional modules on this side, this set of pins, and this is the D out, data out pin. So in another lecture, as I said earlier, I'm going to show you how to connect up to 4 of these modules together. So just plug that display back in. And the first demo, I'm simply going to connect the LED module to the Arduino and display various patterns and text, etc. And then in the second demo, I'm going to also add this accelerometer and then get values out of the X and Y movement data, and then visualize that information from the accelerometer using the display. So I'll put it aside for now, and I am going to continue with the wiring. I'm going to use this flexible ribbon cable first. It's only got 4 pins. The module has 5 pins, so I'm going to use an extra jumper wire where one end is female. Like that, so that's going to be my VCC. Now this is a 5-volt module, so I'm going to plug VCC straight to the Arduino 5 volts pin, like that. I'm going to use the breadboard, this mini breadboard, to help me out. And from what I can see, I've got the second red wire, which is going to be ground, and it ends up being this wire here. Just to make life a little bit easier, I'm going to use black to connect that to ground. Okay. Next, I'm going to plug in the wires for the SPI interface. So I'll start with a yellow wire, and I'm going to connect clock. So clock out of here is the blue. So blue will go to digital pin 13. And I'm going to use, let's see what I have. I'll use orange for the data, So the in, that's orange, so it goes here, and that's going to be digital pin 11 on the Arduino. Then let's go for a white wire. Can you connect chip select? So this one here, that's going to be the gray wire, and that goes to 10. Alright, so these are all the connections completed. Next, I'm going to connect the Arduino, make sure that everything is working. There you go, so the patterns are showing up nice and bright. So let's move along and have a look at the demo sketch and go through it, walk through it, and see how all these patterns come about. Before I do that, what I'd like to show you is where to get the libraries that are required. So first, all the functionality that we see in this sketch comes out of the MAX7219 panel library, which is an extension, or actually builds on the functionality that comes with the Adafruit graphics library. So to get that, just go to this location on GitHub and download the library. Just use the download button, zip it up, and then install it inside your libraries folder of your Arduino IDE. I'm using Arduino IDE version 1.6 here. So here's the first library. I did the same thing for the Adafruit graphics library. So here's the location, just download it and then install it, and let's see, here it is. Now I'm going to go inside the Adafruit library in a second and have a look at the header file. But before doing that, let's continue with the demo sketch and see what we've got in here. Alright, so after we've got the library included, we set the chip select pin to be 10. You can change that to something else. Any digital pin will do for this role. And I've also connected the rest of the SPI pins. Now, we initialize the library by declaring, by creating an object, a matrix object. And all we need to do is to let it know where the chip select pin is, so which of the digital pins is going to be chip select for us, and then how many screens we actually have connected. So 1.1 here means that we have a configuration that contains one displays vertically and one horizontally. So we could go for a configuration that contained, for example, 4 displays, and we have 2 rows and 2 columns, and we'll just say here 2,2 to have a configuration like that. So this library is very flexible. You can create displays of different sizes and different configurations. You can go for square configurations or for say elongated rectangular configurations, and so on. I'm going to play more with this capability in a follow-up lecture. Next, in the setup, the only thing we've got to do is to set the intensity of the LED. I've got a little loop further down where we loop through all the possible intensities, and those are from 0 to 15. So 0 is the LEDs are still on and visible. They're just not as visible. So at 15, they are at the brightest level. And then all the demos happen inside the loop function. So I demonstrate how to create dots, then there's lines, then we have rectangles, circles, triangles, filled triangles. We can also have filled rectangles, instead of just the outline. And then demonstration of text, displaying text, and finally demonstration of changing the brightness of the LEDs. Now I'll pick a couple, and the principle is the same pretty much throughout, but I'll pick a couple of functions to see how in general you go about printing anything you like on a display. The first thing you need to do is to clear the display in case you have something displayed on it earlier. The MAX LED controller contains a buffer, and whenever you want to draw something to the display, the first thing you do is to draw the shape inside that buffer. So drawing to the buffer doesn't actually draw anything on the actual screen. It's just a memory, a bit of RAM in the controller where you can that you can use as a canvas. You can use multiple of these functions, such as draw pixel and let's say draw line, for example. So you can do a bit of drawing using those functions. And then when you have finished drawing on the canvas, on the buffer, you call the write function to copy whatever is in the buffer into onto the actual screen. So you can do things that contain multiple of these fundamental shapes and points. And when you're ready to print something to the module, to the display, you call matrix.write in this case. So back to the dot. If you want to just make a single LED light up, you just need to provide the coordinates. In this case, it's just a 0.0, which is the very first LED right here. So this is 0.0. And then you've got the X coordinate and the Y coordinate. So this is 0, this is 1, 2, 3, 4, and so on for X, and 0, 1, 2, 3, 4, and so on for Y. And the last parameter, number 1, means that I want to make that LED turn on. So if I had 0, then the LED would be off in this case. Just to backtrack very quickly, I can also fill the screen with lit LEDs. So if I had said here fill screen 1, then all of the LEDs on my display would be lit and be bright. So you can see here what I'm doing. I'm drawing 2 pixels in the buffer. So here's the first one, and then I'm going to location 3.4, so X3, Y4, and I'm turning that LED on as well. And then when I'm happy with what I've drawn, I go ahead and call the write function. Then the buffer is copied onto the display, and I can see the LEDs lit. I'm going to stick around with that configuration of the display for half a second, so I insert a delay, and then I move on to the next thing. So what I want to do next is to first clear the screen, so I'm saying fill screen 0, and then draw another pixel at the bottom right corner of the display down here. So to see that actually happening, I'm going to comment out everything and upload the sketch as it is now. Oops. Oh, of course. Okay. I should select the appropriate port. This one. All right. There you go. So that's how you draw single pixels. Let's try out lines. So here we are. I want to draw a couple of lines. Actually, I want to draw more than a couple of lines. So I begin by clearing the screen. So I'll pass a 0 to function fill screen. And then this is how you draw a line. So this is the one end of the line coordinates, and here's the second end of the line coordinates. And I want these LEDs across this line to be lit. So I'll go to the buffer, I call draw line to tell the controller where, what kind of line to draw, from where to where. Then I call the write function and make that line visible on the display. Now what I wanted to do here is to have a line that seemingly moves. So I wanted to create a small animation. So I want that line to move from the first, say, X coordinate down to the last, and to look like it's scrolling. So I just created a loop. So that loop contains, it's going to go around 8 times from 0 to 7, and each time the I coordinate here, which is a Y, will be updated, and after 40 milliseconds I will be clearing the whole screen again and then recreating a line, or redrawing a line at the next row. So let's see what that looks like. I'm going to comment out the sketch before and after this single loop and see what the effect is. There you go. So now you have a line that seems to be moving from top to bottom of the display. What I'm doing next is basically the same concept. It's just that instead of moving from top to bottom, I'm moving from, say, left to right, or from right to left, or from bottom to top. All that is happening by using simple loops. So I think you're getting the idea at this point of what is the general architecture of creating animations and putting things onto the screen. For rectangles, I'm doing the same thing of first clearing the screen, and then I'm using the draw rectangle function. And with draw rectangle, it looks very similar to the draw line function. It's just that we need to specify where we'd like the top left corner of the rectangle to be, and then where we'd like the bottom right corner of the rectangle to be. So here what I'm doing is an animation showing a rectangle. Let me demonstrate. Let's comment out the bits before and after. Okay. So there's the effect that I was trying to achieve. So it's like a minimizing rectangle. Same thing is happening with a circle. I'm now drawing a circle that shrinks from its biggest possible size to the middle of the display. I'm going to let you play with this. I've got a triangle here as well. So draw a triangle. Here you need to specify the 3 tips of the triangle. So that's why you've got 3 coordinates. So here's 1, 2, and the 3rd coordinate. And I want all the LEDs across the edges of the triangle to be 1. But there is a variation of this function called fill triangle. Again, it receives the same kind of parameters, but this time all the LEDs on the edges and on the inside of the triangle are all lit. Now finally, almost finally, we've got text. Text again is very easy to draw thanks to the Adafruit graphics library. All you've got to do is to specify what is it that you want to display, and then to just go through the string and one after the other to display or to draw a character at a position that you specify. So I've got 0, 0 here. Then I'm going through the string. I treat it like a car array, and I pick up one after the other of the characters in the string and print them out. these have to do with the sizes. I'm going to show you what these parameters actually are by looking in the Adafruit library source code. And then I write it. So the effect of this, actually this is worth the effort of commenting out everything else before that part of the code. Okay, so the effect of this is to display one character at a time. Then when I want to move to the next character, I just clear the display and then just display the new character. If you want to achieve this scrolling effect, then you need to do a little bit extra work. And I've got this sample code here, which I also got from the examples that came with the MAX library. So that's a few calculations to try and recalculate the exact position of each character before scrolling it to the next position. So I'll let you study this code on your own and experiment with it. But this is the principle. Now, if I had multiple modules connected the one after the other, then you'll be able to see the text scrolling from one module to the next. So that will make a really nice large display effect. Finally, down here, just play around with the intensity. And you can see it will come up in a second. So you can see that the intensity starts from, say, low intensity, but it's not off all the way to the maximum intensity, as bright as it can possibly be. Alright, so that's the demo. Before we finish this section, I'd like to go to the Adafruit graphics library and have a look at the header. So here in GitHub. And just to show you that pretty much all of the functions that I showed you earlier come from this library. So here's draw circle. Here's the fill circle, triangle, and fill triangle. We've got you can draw a bitmap as well. You can pass a pointer to a bitmap array. You can draw bitmaps and small images. And here's the characters and so on. So everything comes out of here. Okay, so let's move on to the second demo now.